Hello, everyone. Welcome to this session on Amazon RDS Custom for Oracle. Amazon RDS Custom is a new managed database service that was launched late last year for commercial database engines like Oracle and SQL Server. In today's presentation, we will focus on a technical overview of RDS Custom for Oracle. From an agenda perspective, I will break the hour into three parts. In the first 20 to 25 minutes, I will cover a technical overview of the service. What are the key benefits of RDS Custom, its use cases? How is it different from RDS Oracle? And let's also look at the architecture for custom. How is it different from RDS? And also some of the newer concepts that are introduced with custom for Oracle. The next 15 to 20 minutes, we will walk through the demo of the service itself, and we'll have remaining around 10 to 15 minutes for Q&A. Before I dive into the session, a brief introduction about myself. My name is Yamuna Palasamudram. I'm a senior database specialist solutions architect here at AWS. I have over 18 years of experience working with Oracle databases and other Oracle products across multiple industry verticals. On a personal note, I am based out of Chicago, Illinois. Now, let's look at what is Amazon RDS Custom. Now, RDS Custom is a managed database service that was launched in late 2021 under the RDS umbrella. It automates the database administration tasks and operations while making it possible for you as a database administrator to access and customize your database environment and operating system. Now, with RDS Custom, you can customize to meet the requirements of your legacy, custom, and packaged applications. Now, RDS Custom brings the benefits of a managed service by giving you a managed experience in terms of automatic provisioning, backup and restores, point-in-time recovery, automation and monitoring, alerting, and so on. It also gives you flexibility to bring your own media and patches, and also apply those one-off patches in at the pace that you want. And even if you have the need for setting up custom high availability configurations, then you get that flexibility with RDS Custom. Now, the third important benefit here is it gives you granular control by giving full database and operating system access. So you get access to the sys and sysdba privileges to the database itself. And lastly, it gives you the ease to lift and shift your third-party and packaged applications with little to no application changes when you want to migrate to the cloud. Now, many of you might be aware that there are multiple options to run your Oracle databases in AWS. Now, you can choose to run them on EC2, which is a self-managed option, or you can use RDS Oracle, which is a fully managed database service, where AWS takes care of the undifferentiated heavy lifting tasks for you in terms of patching, backup, scaling, HA, and so on, so that you and your team can focus on the application level tasks and more on the business requirements and tasks. Now you have another option to run your Oracle databases, and that is where RDS Custom comes into play. Now, as you see in the slide here, RDS Custom falls in between running your Oracle on EC2 and RDS. Now, for your workloads, our first recommendation is to go with RDS. RDS is a mature service with more than 10 years, and it will give you the most consistent experience. With RDS, the entire database and operating system is fully managed by AWS. But we heard from our customers that there are applications which need administrative rights to the database or underlying operating system, and they need those privileges, those more granular control and privileges to the database or operating system for certain applications. But at the same time, they would want to move to a managed service. And for such use cases, RDS Custom is an ideal option. Now, with RDS Custom, there are more sharp edges as customer retains full access to the resources and can make any change or customizations that could interfere with our ability to provide automation. So there are additional guardrails put in to be able to support the automation. As the saying goes, with great power comes great responsibility. With RDS Custom, some tasks have a shared responsibility between the customer and RDS. Now, let's take an example for that here. You see, like patching and backups are now a shared responsibility. So, in case of Oracle database patching, for example, either a minor version patching or major version upgrades, in RDS Custom, customers have to bring their own media and patch files and create a custom engine version using those files. Then they can use the RDS Custom APIs to upgrade the instance to the latest CEV. So you see that there is a shared responsibility in this case on how patching has to be done in RDS Custom. Now, there are a broad range of use cases for custom. Now, here I've classified them into these four categories. Now, first, custom supports your packaged business applications like Oracle eBusiness Suite, PeopleSoft, JD Edwards, and other applications which need those elevated privileges to the database or operating system. Now, if you're looking for some specific database features like, DB Vault or Flashback, which is currently not supported in RDS Oracle, then for those use cases, custom is an option. Or if you have some third-party agents or drivers that you want to install on the host, on the database host itself, then again, that is supported in custom. Custom also supports applications which you want to lift and shift into AWS as is or with little to no changes, right? Uh, and also the other one is the migration itself. Now, if you want to use native tools like Armin and DataGuard for just to minimize the migration downtime, then those are supported on RDS Custom. And lastly, just as a disaster recovery, if you want to set up a disaster recovery database in AWS with your primary being on premise or on any self-managed option, then you can set up the DR as a data guard standby in RDS Custom. Let's look at the architecture of RDS Custom itself. Now, with Custom, all the underlying resources are now deployed in your AWS account, unlike the standard RDS. In RDS, when you deploy a DB instance, you only get access to an endpoint with which your applications connect to the database. Whereas in RDS Custom, all the underlying resources are deployed in your AWS account. And when you deploy a custom DB instance, apart from getting an endpoint access, you also get full access to the database with sys and sysdba privileges, and also root level access to the operating system. Now, as you see here, you have a VPC where your custom DB instance is deployed. So there is an underlying EC2 instance where your operating system and the database itself is installed. And RDS Custom uses Amazon EBS for the storage. And once you deploy this instance, you will have the endpoint. Now, there is also an S3 bucket where you have to store your installation media. And this is also the place where you'll keep your transaction logs and so on. Now, in addition to these, there is an automation and monitoring layer. Now, this automation software runs outside of your DB instance, and this software communicates constantly with the agents that are running on the database instance. And primarily, there are 3 agents running on the DB instance. They are the SSM agent, the CloudWatch agent, and the RDS Custom agent. Then let's look at a high-level workflow of how to set up and create an RDS Custom DB instance. Now, before you begin, there are some prerequisites that needs to be done in terms of the VPC and IAM setups itself. You also need a KMS key. KMS key is mandatory in case of RDS Custom. So you can either reuse an existing KMS key that you have or create a new KMS key. And also you need a S3 bucket to store your installation media. So once you have all your prerequisites done, and all these prerequisite steps are detailed in our documentation in terms of how to do the VPC setups and also the IAM rules, privileges, policies, and so on. There is also a CloudFormation that's available, which you can use to set up all these pre-steps, or you can do them manually as well. So once you have these prereqs done, now the second step is to upload your database software into the S3 bucket that you have created. Next, you will create an RDS custom engine version or CEV from that media. Now we'll talk about CEV in more detail in the coming slides. But the idea is you will create the CEV from the installation media. And once the CEV is up, then you will use that CEV to create the RDS custom DB instance. Once the custom instance is deployed and up and running, you will get an endpoint similar to what you see in RDS, standard RDS. And along with that, you also get access to the underlying EC2. So you will basically get the SSH key pair, and you can connect to the EC2 instance using the private key. Now, I will go through all of these steps in the demo as well, but this is the high-level workflow of how to create the custom DB instance. These are some of the newer concepts that are introduced with RDS Custom. They are like bring your own media, custom engine version, automation mode, and support perimeter. So let's go through these in more detail in the next 4 slides. So the first one is bring your own media. Now, your responsibility for media is a key difference between RDS and RDS Custom. Now, in RDS, which is a fully managed service, RDS supplies the AMI and the database software. And the Amazon RDS database software is pre-installed, so you only need to choose a database engine and version and create your database. Now, for RDS Custom, you supply your own media. So when you create a custom engine version, RDS Custom installs the media that you provide, and custom media contains your database installation files and the patches. So this service model is called bring your own media. Now, we heard from our customers' feedback that there are some use cases where they need that flexibility to bring their own media, bring their own one-off patches and custom patches, and also uh, you need that flexibility to apply the patches at your own pace. So, with this concept of bring your own model, now RDS Custom supports and gives you that flexibility to apply the patches at your own pace, and also that flexibility to bring and apply your one-off patches and bug fixes. Then let's look at custom engine version. So I've been talking about CEVs in the earlier slide. So let's look at what is this custom engine version. Now, an RDS CEV or custom engine version is simply a binary volume snapshot of a database version and AMI. So you store your database installation files in Amazon S3. And when you create a CEV, you specify the files in a JSON document called a CEV manifest. So you as customers, you have to download the installation files from the vendor website and upload them into Amazon S3. Once the files are loaded into the S3 bucket, you will use those media files to create a custom engine version. Now, this will contain the major and the minor version files required to launch RDS Custom DB instance. Customers are able to, you can actually refer to our documentation where you will find a recipe of the installation files that RDS Custom uses to create the CEVs. So you can use that as an example to create those manifest files. Now you can create multiple CEVs, and you can also create multiple RDS custom DB instances from one CEV. So yeah, there is no like one-to-one mapping, right? You can have one CEV of say 19C July PSU, and you can spin up multiple RDS custom instances from that CEV. And the CEV itself has two states. It can be in the available state or an inactive state. So when it is in available state, basically you can use that CEV to create new custom DB instance or upgrade a DB instance. And this is the default status of any newly created CEV. You can also put the CEV into an inactive state. And when it is in the inactive state, it means you cannot create or upgrade a custom instance with this CEV. So if you have some older versions of CEVs, which you don't want others in the team to spin up instances using that CEV, then you can basically make that inactive. The next important concept is the automation mode. So we saw in the earlier slide that in the architecture slide, right? So we saw that there is an automation software layer that is communicating with the agents on the DB instance. And some of the primary responsibility of this software is to collect metrics and send notifications. And it could be like, for example, when there is some failure of the underlying EC2 instance, for example, your automation will be able to perform automatic instance recovery. Now, you can pause and resume this RDS custom automation. So you can pause for a minimum of 60 minutes to a maximum of 24 hours. Now, probably you're thinking of two things now, right? So first, why do I need to pause the automation? Second, okay, I pause the automation. Now, what happens? What happens when this automation is paused? So let's look at this. Now, if you need to customize your instance, now when I say customize, it could be you have to apply some patches, or you have to do some changes to the database where you want to bring down your database, where you want to shut down your DB instance, or you want to make some parameter changes which needs a restart of the DB instance. Or if you want to make some OS level changes, maybe uh, apply some RPMs, or install some third party agents. So any of those customizations when you have to do, then you need to pause the RDS custom automation for a specified period of time. The reason is this automation pause ensures that your customizations don't interfere with RDS custom automation. So you have to pause the automation, then make your customizations as needed. And then once it is done, you either resume the automation manually or just wait for that pause period to end, after which RDS custom resumes the automation. And again, you can pause for a minimum of 60 minutes. So, but what happens when you pause the automation? The database status monitoring, the EC2 instance status, status monitoring. So these monitorings are paused. And also the custom agent, which is running on this DB instance, is also shut down. And more importantly, the backups, automatic daily backups and manual backups are also paused. So it is, as a best practice, it is recommended that after you make any customizations or changes, when this automation is paused, it is always recommended to take a full backup, right, for a full snapshot of the instance so that all your customizations are saved. Let's look at support perimeter. RDS Custom provides an additional monitoring service called the support perimeter. Now, this additional monitoring ensures that your RDS Custom instance uses a supported AWS infrastructure, operating system, and the database. The support perimeter basically checks for a list of requirements, and if any of these requirements are not met, then RDS Custom considers the DB instance to be outside of the support perimeter, and it will change the DB instance status to unsupported configuration. So you see here how the status in the second screenshot shows as unsupported configuration. Now, when the DB instance goes into unsupported configurations, this time it is your responsibility to look at what caused it and also fix that configuration problem so that the custom can change the instance back into available state. Now, when the status goes into unsupported configuration, you will get notified, and in the logs and events, you will be able to see the messages on why the instance got into this state, and also what you can do to fix it, right? And our documentation has this entire list of, it has basically the list of checks that the support perimeter does. And there are multiple checks that's happening at the database level, at the EC2 level. Just few examples that I can give here is like the agents. Now, RDS Custom expects that these agents are always running on the DB instance. So if the custom agent or the SSM agent is down or is not running, then the instance will be put into unsupported configuration. Similarly, at the database level, now RDS Custom supports only databases in archive log mode today. So if the database is put into no archive log mode, then custom detects that and it will put the instance into unsupported configuration. Now, again, what happens when it goes out of the support perimeter is you cannot modify the DB instance. You again cannot take DB snapshots. Automated backups are not created. So it is important to make sure that your DB instance stays, whenever it goes into unsupported configuration, you need to check that and fix the configuration problems so that it can resume back. Okay, so now we can switch to the demo. Now in the demo, I will show how to create a 19C custom engine version. And we will use that to spin up a custom DB instance from that CEV. And then once the instance is up and running, we will see how you can connect to the EC2 itself, to the database. So we will connect as DBA, we'll also connect as the root, and we can perform few operations. And we'll also look at support perimeter check, and also how we can pause and resume automation, and we can do some perform some activities there. Here I am in the RDS console page. Before I start showing how to create custom engine versions and database instances, let's quickly talk about the prerequisites. First one, you need to have a KMS key before creating a database instance. You can reuse an existing one or create a new one. For this demo, I'll reuse the one which I have pre-created. And then you also need to have IAM roles, policies set up, and also VPC configurations done as well. So here I am in the IAM console. So there is a role which has been pre-created called the RDS Custom Instance role. Now I have used the CloudFormation, which is available in our documentation, to do these pre-setups. So you can use that or configure them manually. Now there is some inline policies that gets attached to this, which gives access to EC2, logs, S3, SSM, and so on. Now there is also an instance profile which gets created, and the role is attached to this instance profile. Later on, while creating the DB instance, I'll show you how we need to reference this instance profile while creating the custom instance. In terms of VPCs, there is one thing, RDS Custom, it needs to communicate from your DB instance to other AWS services like CloudWatch, S3, EC2. So it is going to validate for that network connectivity to these other services. So these are all taken care during the pre-setups. Now the last one is the S3 bucket, where we will have the installation media. So I have a demo bucket created. Within that, I have the 19C January RU patches stored in this S3 bucket. Now that I have these pre-setups, I will go into the console, get into custom engine versions, and say create custom engine. Now this is engine type specifically to Oracle. We support only Enterprise Edition now. I'm going to choose 19C. Give a name here. I'll say demo C1. A short description. And the second section is the installation media. So here you will specify your S3 bucket. And then this is the manifest file we spoke about during the presentation. So here, this is a template that you see here. Now here you need to replace that with the actual file names, right? So these are the files which are in my S3 bucket. This is a JSON document which is sensitive to tabs and spaces. So watch out for that. And also the file names has to match with the actual file names that you download from the Oracle website. Our CEV, before creating the CEV, our APIs is going to do a checksum validation to make sure the files are valid files, right? So once you do that, then next section, I'm going to choose a KMS key and then say create custom engine version. This process can take up to 2 hours for it to complete. So for the demo purpose, I have one CEV pre-created already. So I'm going to use that CEV and show you how to create a DB instance. So now let's create a custom DB instance. So I'm going to say create database. Here, most of the options are similar to the standard RDS. So there are few differences, so I'll highlight them. I'm going to say standard create engine options Oracle. Right, let me just refresh my screen now here. So engine options Oracle. You see here now, you'll be able to see another option, Amazon RDS Custom, which comes only with Enterprise Edition. And this is a step where you will pick your CAV. So I'm using an existing CEV here. And this, I'll leave it as production, which is the standard one. Give a name here. Okay. The next DB instance class is, as of today, custom supports only M5 and R5 instances. For the demo, I'm going to use the default M5 one. Storage, it supports GPE2 and provisioned IOPS. I'm going to leave it with, say, 100 GB just for this test instance. And next section is the connectivity. Now here I'm going to choose this VPC where I have done the pre-setups. And this is my subnet group that I created. I don't want any public access. And I have some security groups with which I can connect. So I'm going to choose my security groups. I will use the default port. And this is where you need to specify the IAM instance profile. So this is the US EC2. I'm working on US EC2. So I'm going to choose that instance profile and then the KMS key. So once you have that, the other difference you notice here is the database automation. So when you're creating a custom DB instance, by default, it will be in the full automation mode. You'll not have an option to pause the automation during creation. And then give a DB name. Backup retention, you can choose up to 35 days, and you can also select a backup window if you wish. And obviously the maintenance window, which is similar to standard RDS. So that's it. So once you have these, you say create database. And this will take around probably 15 to 20 minutes to get it up and running. I have a custom 1 DB instance in the available state. So let's look at this instance and also connect to the EC2. Now, if you see here, this one, the automation mode, it is in full automation. The endpoint and network and security groups are similar to standard RDS. Now, when you go into the configuration tab, you will notice a resource ID. This is the resource ID of the EC2 instance. So I'm going to grab this, go into my EC2 console, and then pull in this particular EC2 instance. So this is my EC2 instance. Its private IP is 10.03.206. And then it has SSH key pair associated with this. So I'm going to grab this SSH key from the secrets manager. So I have this. So if I go into my secrets manager, I have this key over here, right? So this is my SSH key pair. So from here I can retrieve this value, and I'm going to save this as my key to connect to the instance. Now, when you're in the EC2 console, you can also use Sessions Manager to connect. So if I'm here, I can just say connect using Sessions Manager. And this will open up an other tab or a window where you can connect to the instance. So you can use this as Sessions Manager to connect to the database, or you can use any SSH utility of your choice to connect to the instance. Now I have used the private key that I've downloaded from Secrets Manager. I'm just using PuTTY to log into the instance. So this is my IP address of the instance. Now here first when I log in, I'm logged in as the EC2 user. I can sudo to RDS DB, which is the user that owns the Oracle binaries for the Oracle install. So let's do some quick checks here, or some of the things that you would do on a common activities on the database server, right? Now, I see that there is a pmon process running. This is the DB name, CUST1. Maybe I can check the listener status here. The listener is up and running. This is the service name or the instance name that it's serving. Then I can check what volumes are there. So there are two mounts here, RDS DB data and RDS DB bin. DB data has the actual data files, and DB bin has the Oracle binaries installed, or the Oracle home. So we can verify that if I just do an echo dollar on my Oracle home, it is an RDS DB bin Oracle. Then let's also look at, we spoke about those 3 agents that runs on this instance, right? So if I grep for the process, so you see that there is a CloudWatch agent running, there is a RDS Custom agent, and as well as the SSM agent running on the instance. Now, let's see how we can log in SSDB and perform any database tasks in there, right? So I'm in here, I'm logged in as SSDB. I'll just do a query on $database. So this is my CUST1 database. Now here it is very similar to what common database tasks that you would perform on an on-premise environment, any Linux environment. Let's check one more thing here. So for this particular instance right now, my automation is up and running. So I can verify that here. This is my custom one instance and it is in full automation mode. Now I'll go ahead and shut down the database instance and see what happens. Okay. I'm also going to tail my alert log so I can monitor that. Right. Okay, so I will say shut down immediate on this database. So you see that the processes are stopping and the instance is almost shut down. Okay, dismounted. And it is shut down complete. Now, within a few seconds, you notice that the automation tries to bring up the database, and that is what you see here in the alert log. So it brought the database back up. Now, if I might have lost this particular connection, but let's see. Yes, so this, if I re-log in, I'm able to connect to the instance. So this is since the automation was on, it will try to bring the database back up. And so that is the reason if you have to perform any maintenance activities, you have to pause the automation, complete your activities, and then resume the automation back. So now let's see how we can pause the automation. So here I'll show it from the console side. You can do it from the CLI as well. So I'll go ahead and say modify my DB instance. And here under the automation section, you can say paused, and you can choose the time that you want to pause. Now, what are the other things that you can modify? Let's quickly take a look at that. So one is the CEV. So if you want to upgrade to the next patch set level, so you'd have to create a new CEV, and you can go ahead and apply that new CEV in this section, right? You can also modify the storage type. You want to go from GP2 to IO1, also increase the storage, then you can do that modification as well. So now I'll go and say continue, and it will give a summary that you are changing the automation from full to paused, apply immediately, modify DB instance. So now this DB instance will, in few minutes, you'll see that it will go into the paused state. I mean, from the automation side, right? So now you see that this custom instance automation is paused, it resumes in 59 minutes. Now we can also quickly check that we have sudo to root as well. So this is one of my instance. I can sudo to root, and then maybe I'll just do a quick yum update as root user. So here you go. So you can perform any OS level activities as root user. Lastly, let's take a look at one of the support parameter checks. Now I will log in as DBA here, and let's check this parameter archive lag target. What is it currently set at? So it is set at 300. I will go ahead and make this as 0, which basically puts my database into no archive log mode. And RDS Custom does not support a value of 0 for this parameter. So in a few minutes, you will see that the support parameter check will detect this, and it will put the instance into unsupported configuration. So after a few minutes, you notice that the support parameter has put the instance here into unsupported configuration. Now I go into logs and events, and here is a message which says this parameter was changed from 300 to 0, and the instance is running in unsupported configuration because it is out of the desired range, right? And it also gives that the value expected for this parameter is between 60 and 7200. Now, so now since this is in the unsupported configuration, I have to go and fix this, right? So I'm going to go ahead and change this back into 300, right? And then again, within few minutes, support parameter should detect this and put the instance back. After a few minutes, we can see how the instance is now back in the available state. And in the logs and events, we should be seeing the message saying that here the RDS custom instance has resumed, which was previously in the unsupported configuration. Just to summarize, in the demo, we saw how to create a custom engine version and how to create a custom DB instance using the CEV. We also logged into the underlying EC2 instance where the database resides. And we saw that we can now log in as sys. So sysdba into the database, we have that granular control to the database as well as root level access to the operating system. Then we also saw how to pause and resume automation, and for any of the maintenance activities or any custom activities that you want to perform. And we also saw an example of support parameter check, how the instance goes into unsupported configuration, and when it is fixed, how it comes back into the available state. Now with that, let me switch back into the presentation. Okay, so we are almost at the end of the presentation. Before we open up for Q&A, just to summarize, we learned about this new service, Amazon RDS Custom for Oracle. We looked at the key benefits and its use cases. And then also talked about how the custom architecture looks like, how is it different from RDS, and also some of the newer concepts. And then lastly, we went over our demo itself, showing the service and how the workflow looks like when you have to create a custom DB instance. Lastly, I do recommend you to explore this service option for your specific workloads that needs, granular control of the DB or the operating system, or if you have those specific use cases that we talked about in terms of maybe you have to install a security agent or a third-party agent or driver on the DB host itself. And do try out a POC for your specific use case. And if you have any additional questions that you need help on, please reach out to your account team and they will be happy to set up a call with a database specialist who can help you further, with any specific questions or if you need any more deeper conversations. Thank you. Thank you so much for your time. And I hope you found this session informative and useful. I think we will now open for Q&A. Thank you.